Alright, so today in section 2.7 we're going to look at graphing inequalities. You will notice that instead of an equal sign we've got an inequality sign, in this case a less than. We're going to graph both linear inequalities, which means they're going to be lines, or we're going to graph absolute value inequalities, which means they're going to be V's. So let's start with our lines and then we'll look at our absolute value. What I'm going to go through and do is just graph this like I normally would. Looking at this, I have a y-intercept of -1, and I've got a slope of 2. So I'm going to go ahead and graph that. So -1, slope of 2, up 2, rise 2, run 1, and I'm going to keep going all the way across my page and keep going down 2. Okay, now instead of just drawing a line, now you need to think about your inequality symbol. If there's an equal to, you're going to put a solid line. It's like the closed-in point when you're graphing on a number line. It means it can equal this value. If it does not equal this value, like the one we have, it's just less than, you're going to put a dotted line. This dotted line is like an open circle if you're graphing on a number line. The other thing that you need to do is you need to shade. The shading is actually where your answer is. Now this is less than. I'm going to look at my y-intercept, it's -1. I'm going to pick the values that are less than that. So -2, -3, -4, etc. So I'm going to shade down here. Now maybe I should use my highlighter in the biggest value I have. So here's my shading. It's all of this is part of my answer. Now here's what this means. If you were to take any of those points, say this one right here, that's 3, 1. If I were to take the x value and the y value and plug them in here, it would give you a value that was true. Whatever you've got there would be less than this value over here. Whereas if you pick something that's not shaded, if you were to plug that point into here, it would not be true. So your answer is not just the line, it's the boundary here. The line's actually not part of your answer, that's why it's dotted. And then it's all of this stuff over here. Okay, let's graph one or two more lines. Okay, so I have this. This is great, but I do need to get it in y equals mx plus b form. So I'm going to divide by -2. Now remember, when I divide by a negative, I need to flip my inequality sign. And then I'll go through and graph this. So y-intercept of -1, slope of -2, so rise 2, back 1, or I could go down 2, over 1. Your choice. We're going to go both directions anyway. Okay, now I need a dotted line because my line is not part of my answer. There's no equal to. So this is a boundary. It's not actually part of my answer. And then I need to shade where it's less than. So here's -1. It's less than below that. So I'm going to shade down here. Maybe I can get a little bit closer to my line here. Okay, one more line. Now this is in sort of in standard form. If you think back to our forms, let me get it in y equals mx plus b. I'm going to subtract my 3x, bring it to the other side. So graphing this, I've got a y-intercept of 2 and a slope of -3. So I'm going to rise -3, run 1. Okay, now this time I'm going to use a solid line because it is equal to. Now this solid line just means this line's part of my answer. The dotted line means it's a boundary, it's not actually part of the answer. And then I want to shade where it's less than. Man, I should have put one on here where it was greater than. I don't know why I did them all that way. But if I look for where it's less than 2, it's 1, 0. Those are all less than 2. So I'm going to shade here. Okay, and pretend like I got it all shaded in. Okay, so let's graph a couple of absolute value ones. Okay, remember, if there's an absolute value, the graph is going to be a V. Now, I'm going to just put like a +0 on the end here. So I'm going to use my parent function. Instead of starting here at 0, 0, I need to move it over 2, opposite of the direction I think, and up or down 0. So right here. Okay, and then it's got a slope of 1. Now on here, I'm going to have a solid line. Because it has the equal to. Okay, now I'm looking to shade where it's less than. So again, I'm going to look at my y-intercept and I'm going to shade where it's less than, which would be down here. Now on these, get it shaded where it's very obvious to me where your answer is. I know that it may be hard to get every bit of it shaded in, but do your best. Okay, now we're going to look at 2 more of these. These 2 are different because I can't use my parent functions on here. If you look at this, you'll see that the 4 right there messes it up from being able to use my parent function. So what I'm going to do is I'm going to do -b over mc to find my vertex. Now my b, it's like it's +0 right there, so my b is 0. And c is 1. So 0, 1. 0 divided by 4 is 0. So my vertex is at 1. And then I'm going to plug in a couple of points. Now for me, I'm going to use -1 and +1. So if I plug in the -1 here, I'd have absolute value of -4 plus 1, which would be 4 plus 1, or 5. Same kind of thing with the 1. 4 times 1 is 4. 4 plus 1 is also 5. Alright, now I need a dotted line because it's not equal to, so let me try to get as good of a dotted line as I can in here. And then I need to shade where it's less than. So I'm going to find my y-intercept. Here it's at 1. I'm going to shade where it's less than that. Maybe I should get this sign before I start. And then shade all of this in here. Mine's a little messy. You can do yours a little bit neater. Okay, and then last one we're going to do, which we are going to run into the same kind of problem. Looking at this, let me go ahead and move my 2 over. Looking at this, the 3 messes it up from being able to do the parent function. So I'm going to do the -b over mc. So -1/3, 2. There's my vertex. And then from there, I'll plug in a couple of points. Now I'm just going to use, again, -1 and 1. It should work out fine. So inside here, if I plug in the -1, I'll have -3 plus 1 is a -2. So 2 plus 2 is 4. Okay, plugging in the 1, I have 3 times 1 is 3, plus 1 is 4. So 4 plus 2 is 6. Now it makes sense that they are not the same height here because they're not an equal distance from the vertex. Okay, now I need a a dotted line. And at last we have one that's greater than, and so I better make my little highlighter smaller because I'm not sure that big one I had before will fit. Now when it's greater than, looking right here at my y-intercept, it's greater than at 4, 5, and 6. So I'm going to shade inside. On the absolute value ones, you're basically going to shade inside the absolute value, inside the V, or you're going to shade outside the V, one or the other. Okay, so this is 2.7.